What happens when summer becomes so hot that even air conditioners struggle to keep up? That is becoming reality across China, where record-breaking heat waves are pushing electricity demand for cooling up by more than 20% during peak periods. So instead of building bigger air conditioners, Chinese engineers asked a different question. What if entire cities could stay cooler from the start? Today, from smart materials to ancient architecture, China is testing bold ideas that could help keep over 900 million urban residents cooler while using far less energy. Walking outside on a hot day can feel worse than staying inside a parked car. Roads, sidewalks, and concrete buildings absorb sunlight for hours and slowly release that heat throughout the evening. That is why cities often stay hot even after sunset. To fight this, several Chinese cities have started using outdoor mist cooling systems. These systems spray extremely tiny water droplets into the air. The droplets are so small that they disappear before reaching the ground. As the water evaporates, it absorbs heat from the surrounding air. In fact, just 1 gram of evaporating water absorbs around 2,260 joules of heat. Multiply that by millions of droplets every minute, and an entire public space can become noticeably cooler without leaving people soaked. It almost looks like nature decided to install its own cooling system. And unlike blasting cold air into the open, this method uses only a fraction of the electricity needed by conventional cooling systems. Not bad for something that is basically giving physics a full-time job. Here's something that most people never think about. The road under your feet is actually one of the biggest reasons cities become so hot. Traditional black asphalt absorbs almost everything the sun throws at it. During summer, road surfaces can reach temperatures of 60 to 70 degrees Celsius, almost double the normal human body temperature of 37 degrees Celsius. No wonder walking across a parking lot sometimes feels like stepping onto a giant frying pan. Chinese engineers are now testing cool pavements that reflect more sunlight instead of absorbing it. Some materials are also designed to hold small amounts of moisture, allowing evaporation to remove additional heat naturally. Field tests have shown that these roads can stay 10 to 15 degrees Celsius cooler than conventional asphalt under the same sunlight. The result is cooler roads, cooler neighborhoods, and less heat trapped during the night. Think about it. If thousands of streets stop storing heat every single day, the entire city begins to cool down. Sometimes, solving a huge problem starts with changing the ground beneath everyone's feet. Now, this one sounds almost unbelievable. What if a simple layer of special cooling paint could make a building cooler without using electricity? Researchers have developed highly reflective coatings that bounce most sunlight away before it heats the building. But that is only half the story. These advanced materials also release heat into the atmosphere very efficiently through a process called radiative cooling. Instead of trapping heat inside walls and rooftops, they continuously send it away. On a sunny afternoon, a conventional rooftop can become more than 70 degrees Celsius, while some reflective cooling coatings keep the surface 20 to 30 degrees Celsius cooler. That also means buildings need far less air conditioning, reducing electricity use by up to 30 to 40% in suitable conditions. It is funny how something as ordinary as paint could quietly save huge amounts of energy while nobody walking past even notices. Normally, every office tower, shopping mall, hotel, and apartment building has its own cooling equipment. That means thousands of machines working separately. China has another idea. Instead of every building producing its own cooling, some business districts use district cooling systems. A large underground plant creates chilled water and sends it through insulated pipes beneath the streets. Buildings connect to this network and use the cold water to remove indoor heat before sending it back to be cooled again. It works almost like a city's water supply, except instead of delivering drinking water, it delivers cooling. Because one large system is usually more efficient than thousands of smaller ones, electricity consumption can be 30 to 50% lower compared with conventional cooling systems serving the same area. One centralized plant can replace hundreds or even thousands of individual cooling units. Would this work in every city around the world? Maybe not. But in dense urban areas filled with skyscrapers, it makes a lot of sense. Not every solution needs advanced technology. Long before electricity existed, Chinese builders already understood something important. Hot air rises. Traditional homes in some regions included open central courtyards that naturally pulled warm air upward while allowing cooler air to flow through lower rooms. Modern architects are studying these ideas again. Instead of copying old buildings exactly, they are adapting the same airflow principles into modern offices, apartments, and skyscrapers. Carefully designed openings and ventilation paths allow natural air movement to reduce indoor temperatures. Some studies have found these traditional designs can reduce indoor temperatures by several degrees Celsius, even without mechanical cooling. Sometimes innovation is not about inventing something new. Sometimes it is about asking why people stopped using a brilliant idea in the first place. Even if a city becomes cooler, people still spend hours outdoors. Construction workers, delivery drivers, street vendors, and commuters all face extreme heat every day. That is why personal cooling devices have become increasingly popular across China. Portable neck coolers, wearable fans, cooling scarves, and battery-powered cooling vests help remove heat directly from the body instead of trying to cool the entire environment. Interestingly, cooling the back of the neck is especially effective because large blood vessels pass close to the skin in that area, allowing the body to lose heat more efficiently. Think about the difference. Cooling an entire street requires large infrastructure. Cooling one person only requires a device small enough to carry. It is a simple idea, but during dangerous heat waves, keeping body temperature under control can make a real difference. Technology does not always have to be huge. Sometimes the smartest solution is the one that fits inside a backpack. This next idea is probably the most controversial. China has invested heavily in cloud seeding, a weather modification technique designed to encourage rainfall when suitable clouds are already present. Aircraft, rockets, and specialized equipment release tiny particles that help water droplets inside clouds combine and eventually fall as rain. Cloud seeding cannot create clouds from a perfectly clear sky, and scientists continue to study exactly how effective it is under different conditions. Under favorable conditions, researchers estimate it can increase rainfall by roughly 10 to 20%, but it cannot create rain from nothing. The most fascinating part isn't the technology, it's the mindset behind it. Instead of cooling one room at a time, China is finding ways to cool entire cities before the heat even builds up. From smarter roads and reflective buildings to ancient architecture and wearable cooling devices, every solution tackles the same problem from a different angle. Even lowering a city's average temperature by just 1 degree Celsius could save millions of kilowatt hours of electricity every summer. As heat waves become more common around the world, this approach could shape the future of urban living. The future may not belong to the biggest air conditioners, but to the smartest cities. Which innovation impressed you the most? Cooling paint? District cooling? Ancient architecture? Or wearable cooling technology? Share the answer in the comments. If you enjoyed this video, don't forget to like, share, and subscribe for more content.